Hi guys! Welcome sa enginerdmath channel. Sa video na to, ituturo ko sa inyo ang Newton's Law of Cooling. So kung gusto niyo itong matutunan, just keep on watching. Okay, so this time ay ituturo ko naman sa inyo ang one application of differential equation, which is this Newton's Law of Cooling. Okay, so ano ba ang Newton's Law of Cooling? So i-define natin siya para ma-derive natin yung pinaka-differential equation. So sabi, the temperature of a body changes at a rate that is proportional to the difference in temperature between the outside medium and the body itself. Okay, so yung rate of change daw nung temperature ng isang body is proportional doon sa difference ng temperature niya doon sa outside medium. Okay, or yung surrounding. So, kung i-represent natin to into differential equation, let's say we have let T as the temperature of the body, and let's say A is the temperature of surrounding. Then, if we try to apply this definition for Newton's Law of Cooling, so the rate of change daw ng temperature ng body, so meron tayong differential dt over dt dito, right? To denote the rate of change of temperature with respect to time. And then, proportional daw, so equal, so kapag meron tayong proportionality, meron tayong constant, right? Let's say K. Sa difference in temperature between the outside medium and the body itself. So, directly proportional daw siya doon sa difference ng temperature ng body doon sa surrounding. So, therefore, times T minus yung temperature ng surrounding A. Okay, so ito yung ating differential equation for Newton's Law of Cooling. Now, pwede natin tong ma-solve using the method of differential equations na we have discussed so far. So, ano kayang type ito? So, try nating i-distribute itong K. So, magiging dt over dt is equal to kt minus ka. So, pwede kong i-transpose itong kt sa kabila, magiging dt over dt minus kt equals negative ka. So, mapapansin nyo, it is a linear differential equation, right? It is linear in t, where yung p of t natin is itong nakamultiply sa dependent variable na t, capital T, so negative k. And then yung q of t natin is itong expression sa right side, which is negative ka. So, kailangan nating hanapin yung integrating factor. So, integrating factor is equal to e raised to integral ng p of t dt. So, substitute natin, e raised to integral ng p of t is simply negative k dt. Or, equal to sa e raised to negative k, constant naman si k, so igigilid ko na lang, then integral ng dt. Or e raised to negative k times integral ng dt is simply t. So, meron tayong e raised to negative kt as the integrating factor. Now, yung general solution natin for the linear differential equation is t times integrating factor equals integral ng q of t times integrating factor dt plus constant. So, substitute natin. T times integrating factor is e raised to negative kt, right? Equal, integral ng q of t is simply negative ka times integrating factor e raised to negative kt dt plus c. So, try nating isolve. So, parang na to, t over e raised to kt, right? Negative exponent. Equal, so itong negative ka is constant, right? So, labas ko na lang, negative ka integral ng e raised to negative kt dt plus c. So, ito, pwede nating ma-solve. Ano integral ng e raised to negative kt? Simply, e raised to negative kt divided by negative k, right? Negative ka, nakamultiply siya doon, plus c. So, therefore, makakancel natin itong negative k, magiging t over e raised to kt is equal to a times e raised to negative kt plus c. Now, multiply na lang natin both sides by e raised to kt. So, cancel dito si e raised to kt, magiging t is equal to, so distribute. So, a times e raised to negative kt times e raised to kt. Parang cancel si e raised to kt, right? So, a na lang. Plus, this time, e raised to kt times c is c times e raised to kt lang. So, therefore, ito yung expression natin for the temperature of a body T in terms of time. So, at any time T, pwede nating masolve yung value ng temperature. Knowing, meron tayong certain conditions. Kasi, kailangan nating isolve dito si K tsaka si C. So, at least 2 conditions meron tayo. Pwede natin gamitin para masolve si C yung initial condition na ano yung temperature ng body initially. And then, dapat meron pa tayong isang another value for temperature at another specific time para masolve natin si K. Okay? Okay, so para ma-illustrate natin yung derived formula for Newton's law of cooling, ay mag-solve tayo ng examples. For the first one, we have a thermometer reading 18 degrees Fahrenheit is brought into a room where the temperature is 70 degrees Fahrenheit. 1 minute later, the thermometer reading is 31 degrees Fahrenheit. Determine the temperature reading as a function of time, and in particular, find the temperature reading 5 minutes after the thermometer is brought into the room. Okay, so meron tayong given, right? Yung temperature daw nung body initially is 18 degrees Fahrenheit. Tapos, yung temperature daw nung room is 70 degrees Fahrenheit. So, parang siya yung A doon sa formula natin kanina. So, yung formula natin is T is equal to A plus constant C e raised to KT. Okay? So, meron din tayong condition daw na, so yung unang condition, di ba, at time T is equal to 0, kasi initial temperature daw yun nung thermometer, ang T natin is 18 degrees Fahrenheit. Tapos, after 1 minute later, so, at T is equal to 1, yung temperature na daw ng thermometer is 31 degrees Fahrenheit. So, mamaya gagamitin natin to solve for C and K. Tapos, hanapin daw natin yung temperature reading as a function of time, and in particular, find the temperature reading after 5 minutes. So, ito na yung derive natin, right? So, ang kulang na lang is ma-determine natin tong C tsaka K. Masasolve natin tong C tsaka K using these conditions. So, we have T is equal to A, right? 70 plus C e raised to KT. So, solve muna natin si C using this condition. Substitute natin yung T na 0 tsaka yung 18 degrees Fahrenheit sa capital T. So, we have 18 is equal to 70 plus C e raised to K times T is 0. So, 18 equals 70 plus C. E raised to K times 0 is E raised to 0 or 1. So, parang cancel na si E. So, ito na lang. Masasolve na natin si C kapag tinranspose lang natin tong 70. 18 minus 70 is equal to C, or 18 minus 70 is what? Negative 52. So, C is negative 52. Okay, so meron na tayong C. T is equal to 70 minus 52. Pinalitan ko na yung C ng negative 52. Then, E raised to KT. Ngayon, si K na lang. Ngayon, gamitin natin yung second condition. At time equals 1, then temperature is 31 degrees Fahrenheit. So, substitute uli natin. So, temperature is 31 equals 70 minus 52. E raised to K times T is 1. So, we have, so transpose ko dito si 70. 31 minus 70 is equal to negative 52. E raised to K times 1 or K. So, 31 minus 70 is what? Negative 39 equals negative 52 e raised to K. Divide both sides by negative 52. So, we have e raised to K equals negative 39 over negative 52. Or positive na, right? And then, to solve for K, hanapin natin yung natural logarithm of both sides. So, we have ln of 39 over 52 equals, so cancel na dito si E, K na lang, right? So therefore, yung value natin ng K is ln of 39 over 52. So using calculator, masasolve natin yan as what? So K is negative 0.287 or 29. Negative 0.29. Okay? So ngayon, nakuha na natin yung pinaka-final form ng equation. T is equal to 70 minus 52 e raised to yung K, negative 0.29 times T. So, therefore, ito na yung ating temperature as a function of time. Now, ang pinapahanap sa second question is find the temperature reading 5 minutes after. So, plug in lang natin dito yung T is equal to 5 para masolve si temperature. So, 70 minus 52 times e raised to negative 0.29 times 5. So, using calculator, ang masasolve natin dyan is T is 57.8 degrees Fahrenheit. Okay? Next, we have a thermometer reading 75 degrees Fahrenheit is taken out where the temperature is 20 degrees Fahrenheit. The reading is 30 degrees Fahrenheit 4 minutes later. Find A, the thermometer reading 7 minutes after the thermometer was brought outside, and B, the time taken for the reading to drop to 25 degrees Fahrenheit. Okay, so same formula pa rin na T is equal to A plus C e raised to KT. So, yung condition daw natin, yung initial temperature ng thermometer is 75 degrees Fahrenheit at T is equal to 0. And yung temperature daw nung surrounding is, yun yung A na 20 degrees Fahrenheit. And then, the reading is 30 degrees Fahrenheit. So, 30 degrees Fahrenheit after 4 minutes. So, at T is 4. So, hanapin daw natin yung thermometer reading after 7 minutes at hanapin natin yung time kung saan magiging 25 degrees Fahrenheit yung thermometer reading. So, sige, solve muna natin tong pinaka-equation. So, solve natin si C at K. So, T is equal to, yung A natin is 20 plus C e raised to KT. So, at T is equal to 0, C is 75 degrees Fahrenheit. So, actually, itong C, lagi naman, pwede nating isubstitute dito yung initial temperature minus yung ambient temperature or yung A. So, lagi, pwede natin itong maging T minus A. Okay, so pag ginawa natin, magiging T is equal to 20 plus yung T is 75, right? Initial temperature minus, so lagyan natin to ng not to denote initial temperature. So, T naught minus yung temperature nung surrounding, which is A. So, minus 20 e raised to KT. So, T is equal to 20 plus 75 minus 20 is 55 e raised to KT. Now, ang next naman is mahanap si K. So, substitute naman natin yung second condition na T equals 4, tapos yung temperature is 30 degrees Fahrenheit. So, 30 is equal to 20 plus 55 e raised to K times T na 4. So, we have transpose 30 minus 20 equals 55 e raised to 4k. So 30 minus 20 is 10 equals 55 e raised to 4k. Divide both sides by 55. We have 10 over 55 is equal to e raised to 4k. Then find the natural logarithm of both sides. We have ln 10 over 55 equals, cancel si e, magiging 4k na lang. So therefore, divide both sides by 4. K is equal to ln 10 over 55 divided by 4. So, using calculator, anong masasolve nating value? Equal siya sa negative 0.426. Okay, so therefore, meron na tayong pinaka-equation ng temperature as, so, T is equal to A, 20 plus C kanina is 55, right? Then, E raised to K na negative 0.4260. Okay, now yung required is hanapin daw natin yung temperature 7 minutes later. So, substitute lang natin sa T yung 7. So, T is equal to 20 plus 55 e raised to negative 0.426 times 7. So, using calculator, ilan ito? So, T is 22.79 degrees Fahrenheit. Okay? Now, yung another question sa B is the time taken for the reading to drop to 25 degrees Fahrenheit. So, this time, given yung final temperature natin. So, we have 25 equals 20 plus 55 e raised to negative 0.426. This time, yung unknown is time, T. Okay? So, therefore, we have transpose ito si 20. So, 25 minus 20 equals 55 e raised to negative 0.4260. Divide both sides by 55. Cancel. So, therefore, we have, ano yung 25 minus 25 over 55 equal e raised to negative 0.4260. Then, ln both sides, we have ln of 5 over 55 equals, so cancel si E, magiging negative 0.4260. Then divide both sides by negative 0.426 to solve for T. So therefore, T is equal to ln of 5 over 55 divided by negative 0.426. So using calculator, ilan yan? Okay, so approximately 5.63 minutes. Okay? Next, we have at 2 p.m., a thermometer reading 70 degrees Fahrenheit is taken outside where the air temperature is negative 10 degrees Fahrenheit. At 2:02 p.m., the temperature reading of the thermometer is 26 degrees Fahrenheit. At 2:05 p.m., the thermometer is brought inside where the air is at 70 degrees Fahrenheit. What is the thermometer reading at 2:09 p.m.? Okay, sige, analyze natin. So, yung starting time daw is at 2 p.m. So, parang, yun yung at time t is equal to 0 natin. Yung thermometer reading or initial reading ng thermometer is 70 degrees Fahrenheit. Then, taken outside where the air temperature is negative 10 degrees Fahrenheit. So, sa formula natin siya yung A. So, negative 10 degrees Fahrenheit. At 2:02 p.m., the temperature reading of the thermometer is 26 degrees Fahrenheit. So, since nung 2:02 p.m. daw, parang lumipas yung 2 minutes, right? So, at T is equal to 2, yung temperature daw ng thermometer is 26 degrees Fahrenheit na. Okay? Tapos, nung 2:05 p.m., the thermometer is brought inside na, where the air is at 70 degrees Fahrenheit. Okay? So, what is the thermometer reading at 2:09 p.m.? So, kuhaan muna natin yung pinaka-equation ng thermometer. So, same pa rin, T is equal to A plus C e raised to KT. So, sabi ko yung C laging A plus yung initial temperature na T0 minus yung ambient temperature na A. Okay? E raised to KT. Now, solve ngayon natin C. So, T is equal to A is negative 10 plus T0 is 70, right? So, 70 minus A, negative 10, then E raised to KT. So, we have T is equal to negative 10 plus 70 minus negative 10 is 80. So, 80 E raised to KT. Now, solve ngayon natin si K. Using the second condition na at T is equal to 2, ang temperature is 26. So, we have 26 is equal to negative 10 plus 80 E raised to K times T na 2. So, transpose ko si negative 10, we have 26 plus 10 equals 80 e raised to 2k. So, 26 plus 10 is 36 equals 80 e raised to 2k. Divide both sides by 80, we have cancel e raised to 2k is equal to 36 over 80. Then, find the natural logarithm of both sides, we have ln of 36 over 80 equals, cancel si e, 2k na lang. Divide both sides by 2, masasolve natin si k as ln of 36 over 80 divided by 2. So, using calculator, ilan yan? So, k is approximately negative 0.399. Okay? So, meron na tayong pinaka-equation ng temperature. So, T is equal to negative 10 plus si C kanina is 80. So, 80 e raised to negative 0.399k times T. Okay? Ngayon, sabi, binalik daw yung thermometer inside at 2:05. So, therefore, ano yung magiging temperature niya at 2:05 p.m.? So, parang lumipas ngayon yung 5 minutes from 2 p.m. So, kuhain muna natin yon. So, T is equal to negative 10 plus 80 e raised to negative 0.399 T na 5. So, ang temperature na nung ating thermometer at 2:05 is, using calculator, so it is 0.881 degrees Fahrenheit. Okay? So, ito yung magiging initial temperature niya nung pinasok na siya uli sa loob. Kung saan daw yung air is at 70 degrees Fahrenheit. So, gamitin pa rin natin dito yung formula na T is equal to A plus C e raised to KT. Kung saan, itong C, ang formula natin dito kanina is, so, T0 minus A, right? So, therefore, ang isa-substitute natin dito para masolve si C is, itong T0, yung initial temperature niya na 0.881 minus yung ambient temperature, bale, na this time is 70. So, parang we have T is equal to A na 70 plus C will be T naught. So, 0.881 minus A, 70, then E raised to KT. So, yung sa K naman, similar K pa rin yung gagamitin natin kasi same thermometer pa rin naman yung ginamit natin, right? So, therefore, yung nakuha natin na negative 0.399 times T. Okay, so ilan na to? T is equal to 70. So, 0.881 minus 70 is negative 69.119 e raised to negative 0.399t. So, ang tanong, ano raw yung temperature at 2:09 p.m.? So, anong T isa-substitute natin ngayon dito? 9 ba? Hindi. Kasi, ang reference na natin dito is from 2:05. Kasi dun siya unang pinasok uli, right? So, therefore, ilang minuto yung lumipas from 2:05 hanggang maging 2:09? 4 minutes. So, therefore, yung T natin is 4. Okay? So, T is equal to 70 minus 69.119 e raised to negative 0.399 times T na 4. So, ito na yung magiging temperature nung thermometer at 2:09 p.m. So, using calculator, ilan to? So, it is 55.991 degrees Fahrenheit. Okay? Okay, so I think that's it for this video, Newton's Law of Cooling. So, madali lang naman siya. So, meron naman na siyang derived formula. So, ang pinaka-goal nyo lang is masolve nyo muna yung mga constant, yung C tsaka K, and then, tsaka nyo i-analyze kung ano yung mga given sa problem. Okay? So, sana ay may natutunan kayo sa video na to at maraming salamat sa panonood.